Hello, this is Mr. Huff. Let's talk about whole and whole notes. And this is also found in Activity 7.2 in my PLTW. So let's look at this. So there are several different sorts of whole definitions that are used in ANSI standards. So the first one we'll talk about is a whole that is through. So that means the whole goes completely through the part from the top to the bottom, or all the way through left to right, or front to back. The next kind of hole is called a clearance hole, and the idea behind this is this will accept a bolt, and the bolt will slide through there. It will not grip the bolt in any way, so this would allow you to drop the bolt through, and then you can tighten it without having to screw the bolt through. That's the point of that. So you're allowing something to pass through without gripping it. And then the third kind on this slide is the blind hole. This means that it does not go all the way through. So you have to specify a depth when you use blind holes. Continuing with the definitions, we have a countersink, and if you look at the diagram, it shows that it has a tapered top. It is bigger on the top than it is when it starts the threaded portion, so it angles in. A lot of times there's a screw called a tapered screw that has an angled head like this, so when you tighten it down, the top is smooth, but it has a screw holding the piece down. The next thing is called counter bore, and instead of using taper, the walls are straight up and down, and this is used for when you need a bolt to clamp something down. So a lot of times what this lets you do is put a bolt in there, and it can be recessed so the surface is smooth, but you can tighten it down so the grip is very, very tight. And then the last idea, when a hole is threaded, it's referred to as tapped. I'm probably going to say threaded rather than tapped, but the technical term is tapped out. So tap and die is what you use to cut those, and so if you see the threads in there, it's got a tap. These are the symbols you will see for the whole notes. So we have the circle with a slash through it, that means the diameter. You see the counter bore, or spot face. This is where you have a hole that's drilled, and at the bottom it's flat instead of pointed. The countersink symbol is the tapered little point, and then you would have to define the angle of that taper. And then you have the line with the arrow over it. This is showing how deep your blind hole is going to go. These are some of the examples of the notes that are attached. So in this case, it starts with a diameter, and it's 0.25 inches. It is a blind hole that is 0.75 inches deep. There is a counter bore symbol or a spot face symbol here, and it is 0.38 deep. That doesn't make sense. And it's it's 0.38 wide, and it's 1/4 of an inch deep. Okay, so if you saw this in profile, it would have a 0.38 inch top, go down 1/4 of an inch, constrict to 0.25 inches, and continue 1/2 an inch down. Alright, this is a blind hole, so it is a diameter of 0.38, and it's 0.5 inches deep. And this one is a 0.38 inch hole that goes all the way through the part. So that's kind of how to read those notes. Similar on this, you can see on this one it has a little taper, and that's telling us that the end of this hole was done with a pointed bit, even though it goes all the way through. Is that what it's telling us? No, that's the countersink. I'm very sorry. So this is a countersink hole. So if you saw it from the side, you would see that the top of the hole is 1 inch, then it would go down at 82 degrees, and then it would start the 1/2 inch hole. So it's tapered out from a 1/2 inch to 1 inch. There are two methods of identifying the threads for the thread notes. The ones that we are going to be using, since we're using customary measurements, we'll be using the Unified National Thread method. And you also need to be aware that there is a different method for metric measurements that give usually a little more information, but we'll focus on the Unified National Thread measurement. So you'll see UN to shorten that, so that's Unified National when you see UN. Alright, so here's our thread notes. The first number you see is 5/16. This is the diameter of the bolt or screw that's going to go in this hole. The next number is referred to as TPI, and it's threads per inch. And in this case, every inch would have 18 threads. And then we see Unified National, and then usually there's one of two letters there, C for the coarse threads and F for fine threads. So the coarse threads, you'll have a lower threads per inch, and the fine threads, you'll see a higher threads per inch value. And this is how to interpret the ISO thread notes. Starting from the front, it's metric. It has a nominal diameter instead of a major diameter like we do with the Unified National. It tells us the pitch of the threads rather than threads per inch or centimeter. So the pitch is the distance from one thread to the next. And then it has some other notes here. The H is for allowance, and through is for its priority. And also that 6 in there is a grade. So it does have a lot more information with the notation. But once again, since we're using customary, we will be using the Unified National version. And that's all we have to say about holes and threads.